So our second and third equations on this exercise here, both are equations that involve fractions. So there's some fractions floating around in your arithmetic, which on the one hand ratchets up the degree of difficulty a little bit, because it means that the arithmetic that you'll be doing when you solve these equations is not as cut and dried as it was when we were just working with whole numbers. But this is one of those things that the sooner you can get comfortable having fractions in your life, the better. And I'm also going to suggest that the sooner that you can get the fractions out of your life in these problems, the better. So get comfortable having them, but also develop a strategy for getting rid of them as soon as possible. Because the sooner you get rid of your fractions, the sooner you can get back to a place where you're not making as many arithmetic errors because of errors in your fraction arithmetic. So we may talk about two different ways of doing part B. Let me hear from somebody that did part B in a way that you thought was as quick as possible. What did you think you did to start part B that worked really well to solve this problem quickly? Okay, so you're saying, let's start this problem by multiplying on both sides by 4 over 3. So now here's my first question to you. In part A, you told me that what we should really do to solve negative 4x equals 24 is to first divide. Now you're telling me that what we should first do is multiply. Why the change? PEMDAS. PEMDAS? All right, well, how does PEMDAS tell us that we should change that around here? Yeah. Why would we choose to multiply here? What operation is connecting 3/4 with x in that original equation? Multiplication. It's, again, that secret, hidden, tacit multiply sign in between the number and the x. So 3/4 times x. How do we undo a multiplication with a multiplication? Courtney, tell me more about that. Something you expand on. I completely agree with you. Just to raise the volume a little bit.
You have to divide x by 3/4.
Aha. Right. So secretly, what we really want to do is the same thing that we did in part A. Divide by whatever is multiplying x. So by that same principle, we want to divide by how much? Divide by 3/4. Because what's preventing x from being alone is it's being multiplied by 3/4. So to undo that, we should divide by 3/4 on both sides, which I 100% agree with, and actually I want to start out in this solution by doing it that way. So if I divide by 3/4, so I'm going to write that in on the left-hand side here, divide by 3/4, then I think we can all agree that what's going to be left over after dividing 3/4 x by 3/4? X. For the same reason that x was by itself after we divided negative 4x by negative 4. Right? We divided by whatever x was multiplied by, and x ended up by itself. But if I do it on the left-hand side, I also have to do it on the right-hand side. And so what arithmetic do we end up needing to do on the right-hand side of this equation? Yeah, exactly. Because, and I'm going to write this out, I'm going to expand it by a step. We're dividing one fraction by another fraction. 1/6 divided by 3/4. And so now we have to go back into the memory banks, into Module 1, and remember, how do you divide fractions? How am I going to divide 1/6 by 3/4? Right. So now we followed the trail all the way to why Courtney agrees with Matt. Right? The two of you agree because multiplying by 4/3 is exactly the same thing as dividing by 3/4. That is, in fact, how we divide by a fraction in the first place. Flip the second fraction, the divisor. Replace it by its reciprocal, 4/3 instead of 3/4. And when that flip happens, what else do we do? Yeah, we replace the division with multiplication, which goes straight across. Exactly. So divide fractions by multiplying by the reciprocal, 1/6 times 4/3. And multiplying fractions means multiplying straight across. 1 times 4 is going to give me 4, and 6 times 3, 18. And what's the simplest form for 4 over 18? 2/9. Because 4 and 18 are both divisible by 2, we can reduce this fraction into its lowest terms by dividing the numerator and denominator by 2. And there you have it.